Before we discuss factoring polynomials, let's review what we know about factoring numbers, and in particular about factoring integers, which are the numbers that we talk about factoring. A factor of an integer is another integer so that I can multiply that by something and get the first number. So for example, 2 is a factor of 10 because 10 is 2 times 5. So if I can come up with something to multiply by and get the original number, that's a factor. Two-factor, we also use this word as a verb, is to determine the factors of an integer. A prime number is an integer whose only factors are itself and 1, positive or negative. And then we think of the prime factorization of an integer as writing that integer as a product of primes. We can find the prime factorization by making a factor tree. So what's a factor tree? So I'm going to use a factor tree to find the prime factorization of 18. So I'm going to start by writing 18 at the top. And now I'm going to say, think of two numbers that I can multiply together to get 18. Well, 18 is 6 times 3. Can I think of two numbers I can multiply together to get 6? Yeah, 6 is 2 times 3. Can I think of two numbers I can multiply to get 2? Well, no, 2 is a prime number. What about 3? 3 is also a prime number. This 3 is also a prime number. When I get to a prime number, I circle it so that I know I'm done with that branch. And then when I have the ends of all of my branches circled, I know that I've fully factored my number into primes. Now, when I said think of two numbers that I could multiply to get 18, 6 and 3 wasn't my only option. I could also have said 18 is 9 times 2. But then 9 is 3 times 3. Each of the 3's is prime. The 2 is prime. Either way, 18 is 2 times 3 times 3. Or in other words, 18 is 2 times 3 squared. Now we're going to make use of the prime factorization of numbers a little bit later on. But also, this is just kind of getting us the idea of what it means to factor something. And also for integers, we know that we can always uniquely factor any integer into prime numbers, up to negative signs, right? So 10 is 2 times 5. We could switch the order, it's 5 times 2. Or we could change the sign, negative 2 times negative 5. Those are all the same factorization for purposes of this uniqueness, right? There's no fundamental difference in the way we're breaking down this number. This is a theorem. It can be proved. It's kind of one of the major pieces of business that one does in number theory, is proving that any number can be factored uniquely into primes. So we're not going to do that right now. But it's not just something that's because we said so. It can be proved. So that's factoring a number. At this point, we're going to take this concept of factoring a number, breaking it down into a product of smaller numbers, and translate that concept now to polynomials.